So I'm really happy to be here, and thank you, Megan, for persisting with the invitation. I'm really sorry that we couldn't do this a year ago in person, but that's the way these things have all worked out. So I am going to spend a second or two talking about environmental psychology. And I don't know if you're planning on sharing slides later or not, but if you do get this as a PDF, there will be a link directly to our chapter in the e-handbook. Talking about environmental psychology. My colleagues and I were really happy to have that opportunity to introduce the content to folks, because it's not perhaps the best known part of psychology. Although I will say that recently I have seen ads for environmental psychology jobs in universities, and that, quite frankly, is a first. So I think we're starting to get our foot in that door. What we're doing as environmental psychologists is to study the interactions between people and their physical surroundings. This arose, well, some would say it arose in the 1950s with some work that Robert Sommer, who sadly died just a few weeks ago, did in Saskatchewan, in fact, at a place called the Weyburn Psychiatric Hospital, where he studied how the organization of the common rooms might either bring people together or push them apart. So he did some really classical work there. So the roots of environmental psychology can be said to be in Canada. That's one side of it. So how we experience and change our physical environments, and also how the environment changes our behavior and experiences. So one thing that many environmental psychologists are focused on is how to encourage environmentally responsible behavior. So you see a bicycle in this photograph. It might be about encouraging people to bike to different places and not use their cars. But another thing that we study is how the space itself can influence people. So you can see now I've got big skylights in this space, and it looks very different. And you can imagine that if you were in the space, it would feel very different if you were in the space when it had the skylights versus when it didn't. And that's another big area of research for environmental psychologists. And what do they do? Well, as you can read in the chapter, there are environmental psychologists who work in academia. Of course, I studied with one, Robert Gifford at the University of Victoria. But they also do research and development in industry and in government. And mine is really an R&D job in government, so you'll hear a lot about that in the rest of the talk. Some also do consulting, so they might be on the staff of an architectural firm. Only really a big firm would have someone with that expertise. There are also some who do kind of one-off consulting jobs. One of my co-authors on the chapter, Lindsay McCunn from British Columbia, does a little bit of that kind of consulting work on the side in addition to her research work and her job as a university professor. Some work in policy development, so they might actually take what they know as psychologists, but go into jobs in government departments where their jobs are not to do research, but to understand how to apply research in terms of developing government policy. And you might have heard about government units that do what's called nudging, try to set up programs in such a way that people are more likely to engage in the behaviors that are going to be environmentally responsible, or in some cases responsible for their own health and so forth. A clear example of that would be programs that are designed to reduce smoking in the area of health psychology. They're also active in doing advocacy. Sometimes that can be actual paid advocacy. One of Professor Gifford's former students works for an American organization called the American Council for an Energy Efficient Economy. And his job is to try to bring behavioral research to the awareness of people who develop government policy. We also do policy development or policy nudging and advocacy in organizations like the CPA, which very recently, I think it was just last week, issued a position paper called Addressing Climate Change in Canada, the Importance of Psychological Science. And Dr. McCunn and Professor Gifford and I, among others, were active in developing that position statement for the CPA, which you can read on the CPA website. So my day job is in the National Research Council of Canada, which is possibly one of the better kept secrets of Canada. We're a Government of Canada R&D organization. We've actually existed since 1916. And if you listen to the CBC, you can hear the NRC time signal every day at 1 p.m. local time. So it's out there, but many of us don't necessarily encounter the NRCI every day, even though, as you can see on this map, we have research facilities all the way from St. John's in the east to Victoria in the west, although of course we're really kind of focused here in Ottawa. We have a broad mission to do excellent research and innovation to improve Canada and the world. And we do that in three ways. We do some fundamental research, and some of what I do falls into that bucket, although not much. We do research that supports government priorities. A lot of what I do falls into that area. And also we do research that supports innovation and industry and business development. So we have those three kind of aspects to the work that we do, and that makes us quite different than many government departments who are focused either on program delivery or on policy development. And as you might expect, as any good organization does these days, we try to articulate our values, and these are currently articulated as integrity, excellence, respect, and creativity. The NRC is divided into 14 research centers. I don't have time today to talk about all of them. And as you can imagine, since our focus is all areas of science, a lot of them don't have a whole heck of a lot to do with psychology, although there are psychologists in several research centers. So although I'm going to talk about construction research and environmental psychology, if that's not your particular interest in psychology, you might want to know about the work they do in the Digital Technologies Research Center, the Aerospace Research Center, Human Health Therapeutics, and in particular medical devices, all have elements of psychology in them. The Construction Research Center has had different names, but it's been around since 1947. Most of my colleagues are engineers, building scientists, physicists, some architects, and people who are active in developing building regulations as well. I'm part of the Intelligent Building Operations Unit, and I'm going to talk a little bit more about that in a minute. I also have colleagues who do behavioral science and experimental psychology who are in the fire safety unit. And as you can imagine, they have kind of an exciting job sometimes because they actually have a burn hall where they burn things down, although that's quite separate from the behavioral research they do. So in intelligent building operations, we have a really multidisciplinary staff. And so it's not like a psychology department where you have, individual professors and they build up their own personal labs and their own personal set of research topics. It's much more interactive, and rather than sometimes in psychology departments, I find people think of multidisciplinary as working with a sociologist or working with a political scientist, maybe if you're getting really kind of out there. In this area, you have to be able to talk the language or at least communicate effectively with physicists, as I said, with engineers, and with people whose backgrounds might not even include an intro psych course. So that can be quite a challenge sometimes, but it also makes it fun because I learn a lot from them along the way. Our whole area of research encompasses pretty much all aspects of the interior environment. There are environmental psychologists who study exteriors and natural environments, but that happens not to be the focus of what I do. And one of the things that is characteristic of an R&D organization of any kind and different from an academic job is that you don't get as much freedom to choose your own research topic as you would in an academic job. So I'm employed in a particular unit. We have a focus on indoor environments, and that means that my freedom to do work in other topics, so looking at fostering behavior change to include more recycling, for example, is pretty limited. So you give up something when you go into an academic job, but when you go into a government job, not in an academic job, but you gain something as well because you get that exposure to a much broader range of other colleagues in other fields, and that can be really exciting and lead to new and unexpected directions of work. Now, Professor Norris gave a little bit of an introduction to my path. It was pretty long and winding, and I think it's worth spending a minute or two talking about because to some degree, it's kind of don't do what I did. I started off in Winnipeg. I'm a Winnipegger as my roots, and I did actually 2 degrees at the University of Manitoba. I started out in science and then discovered psychology as a second-year elective and went, wow, this is great. I really want to do that. And ended up finishing 1 degree and then going on into psychology. And then, as she mentioned, I did go to Queen's for my master's. I studied with Professor Jerry Wild, who sadly died a few years ago. Realized quite early in my year that although Queen's is a great place, it wasn't the right place for me in the long run. So I left after my master's and went to the University of California, Irvine, which is, as you can see from the map, a very long way away from Kingston and a really different environment. And as you can see as well, it was the late 80s and it was a pretty expensive time to be a Canadian because the exchange rate was not in our favor. So I realized after a year in Irvine that although social ecology was great and my supervisor there is a great guy with whom I'm still in contact, I couldn't really afford to stay there long enough to get my PhD. So I left Irvine and moved up to Victoria. So I didn't do a degree in Irvine. I took a bunch of courses. They were mostly transferable, but not entirely. One thing, if you move around, you'll find is that, excuse me, every university believes that their statistics training is the best statistics training, and you must take theirs. You cannot transfer it. So I did take much of the same statistical content in 3 places, in Queen's, in Irvine, and again in Victoria. So it's a lot of repetition, but as anybody who's taken stats knows, repetition's a good thing because you learn it better. So I see a value in doing that in hindsight, but it was expensive and painful to move, 1,500 miles 3 times in a row, 3 years in a row. So that's the part I wouldn't recommend doing. But that being said, I have a really diverse set of friends. I'm in contact with people from all of those same places. Even today, I have friends that I did a master's degree in Kingston with. And I have a really great network. So networking, as you heard in previous presentation, excuse me, is really important. Making friends wherever you are is important. So that part is something I recommend, but maybe without quite the same sort of personal upheaval as moving as far as I did. So what do I do? Well, one way to characterize environmental psychology is that it's a perspective on all fields of psychology. And I think that really comes through in the way that I have to build my environmental psychology career. I do some sensory psychophysics, and you'll see an example of that in an experiment I'm going to talk about in a minute. I do some cognitive psychology. I'm quite interested in the effects of the spectrum of light to which we're exposed and its influence on the work that people do in offices mostly, but in other places as well. Because of the workplace connection, some of what I do is more characterizable as industrial organizational psychology. One of the things that I've studied a lot over my career is the effect of work environments on people. And that leads into understanding things like organizational commitment, intent to turnover, and job satisfaction. And because I'm in the organization that I'm in, I ended up having to be involved in some projects on household adoption of smart energy technologies. And I'll be frank in saying that was not my first choice of a project to be involved in, but I have colleagues who were very engaged in trying to understand how to integrate smart home technologies in electrical grids for the purposes of helping utility companies to manage electrical loads. And they needed some expertise in how to engage people, how to ethically conduct research with people in their homes, how to survey people and make any sense of the data that come back. And so I've ended up being involved in a number of projects along those lines that maybe wouldn't have been my first choice, but actually it's interesting work and good people. And if it's successful in the end, it will have a really important effect on our ability to manage renewable energy systems in the future, and that's going to be very important as part of responding to climate change. If you get these slides later, you'll see a link there to an article in the APA Monitor a couple of years ago that describes some of that work in a little more detail. So as you can imagine from what I've just said, I do a lot of different kinds of investigations. Sometimes what I do is lab experiments. For example, the work you're going to see in a minute is a laboratory experiment looking at a light condition on visual performance. Some of what we do, another experiment that I'll talk about in a minute, concerns different kinds of lighting system in a simulated office environment and its effects on people to do work. So a lot of different lab experiments, and one of the strengths of the organization I belong to is that we have great facilities and great technical support to enable us to collect lots of different data in those facilities, things that I certainly don't have the skills to build or run myself. So that's one of the brilliant pieces of the job that I work in. We also do a lot of work in the field. It's true that environmental psychology is all about understanding people in the places where they actually inhabit. And so a lot of our research involves going out to those places. Um, my colleagues and I were quite involved a few years ago in looking at the indoor environmental quality of green buildings, which are built to achieve some sustainability goals, versus conventional buildings, those that haven't had the modifications to achieve those sustainable goals. And that involved data that we collected in, at the time, 24 different buildings across North America. You can do a lot with online surveys to get the occupant information for those buildings, but to get the actual conditions in the buildings involves traveling to them and collecting data on site. So it can be pretty involved stuff. I was involved a few years ago in looking at how to do energy efficient lighting retrofits in an Arctic setting. And this actually was at a Canadian Forces station on Ellesmere Island, CFS Alert. So as far north as anybody lives on the planet. I didn't get to go there, too bad, but we did get to survey people out there, and we influenced the choice of energy efficient lighting in a way that we were able to demonstrate made life better for people who were living for 6 months at a time in this very northern setting. And as I mentioned, I've been involved in some work looking at the integration of smart home technologies, looking first at smart thermostats, their acceptability, and whether or not people would be willing to allow utilities to modify thermostat settings in order to moderate electrical demand. So that also was a field investigation. We also do a lot of literature reviews. That's a pretty important tool that anybody has available to them today. Right now, I'm engaged in a systematic review looking at activity-based workstations and what effects those have on organizational productivity outcomes. Activity-based workstations are unassigned, so you might have 1,000 people who were nominally assigned to a given building, but you might only have 600 chairs in the building for them to sit in. The expectation being that the rest of the time they're going to work someplace else. That's an interesting approach. It can certainly save on the real estate costs for organizations. We're trying to look at those approaches and compare them to other kinds of office design strategies to see if that has an overall beneficial effect on the people who work there. Because it's one thing to say, I can save so much on my real estate. It's something else again, though, if it harms people's ability to do their work, because the people themselves are actually much more expensive to an organization than the space. So we're trying to look at what the literature tells us on that front. And I'm also collaborating with some folks at the University of Ottawa on a systematic review of the effects of light exposure on mood, sleep, and cognitive performance. You've probably seen lighting a few times through this presentation. That's really my first love as an area of research. So I try to do as much of it as I can. That's about a third now of the research portfolio that I have. And in the area of lighting research, one of the most important questions is, apart from vision, what effects does light have on sleep and mood and cognitive performance? And in particular, how much light exposure should people have? And that's a really, sounds like a simple question, right? Throw a meter out, tell you how much light is out there. It's actually a very difficult question to answer because the processes that these effects are responding to actually start with different photoreceptors in the eye than the ones that mediate vision. And so we need a different way to measure how much light people are being exposed to. And again, what we're trying to do in this systematic review is to integrate the research that was done over many years, some of it long before we knew how to measure these exposures for these other effects, and come up with a coherent answer that gives us some guidance as to how much light exposure people really need. So I'm going to talk about a couple of research examples to give you a flavor of the breadth of the things I do, and also of the applications of some of that work. This is a very busy slide because I tried to cram one experiment onto one slide, and it's a challenge. So we're going to start by talking about what stroboscopic visibility is. You can see on the upper right of this slide, a black disc, it's round, and on it is a white dot. So if this black disc is sitting still, that's what you would see, one white dot. If you make the disc rotate, what you will see is going to depend on the light that's falling on the disc. Now you can characterize this light using a quantity called the stroboscopic visibility measure, SVM. And it is an integrated measure that I'm not going to explain. It's not important for my point today. But it's an integrative measure of the rate at which the light output varies over time, because all lights do actually vary slightly in their light output over time. When the SVM is 0, what you would see when that disc rotates is a smudge. But if the light is modulated, it basically goes on and off some number of times per second. The more of that on and off there is per second, the more you're going to tend to see a series of white dots instead of a white smudge as the disc rotates. So you can see on the left-hand side of the slide, SVM is 0, you're seeing a white smudge, and then at 0.4, it's still pretty smudgy. 0.9, it's pretty smudgy, but you can just maybe begin to see the white dots. 1.4, the dots are starting to be evident, and then at 3, the dots are really evident. And effectively what your eye is doing is it's almost seeing like a snapshot of the disc as it goes around, and you're able to articulate each individual dot as it goes around. Now, of course, the photographs are showing you what my iPhone camera saw, not what your eyeball saw. So what we wanted to do in this experiment was to determine the probability with which people would see the white dots under these different light sources. And we had 5 different LED lamps that had this SVM characteristic, clearly distinguished between them. When I say we, I actually did this in collaboration with a colleague in France at Centre Scientifique et Technique du Bâtiment, CSTB. And so it was a little more complicated to determine exactly what light sources we would use because of electrical differences between France and Canada. But we were very clear that we had 5 different independent levels of our independent variable, and half the data were collected in Canada and half the data were collected in France, and then we combined the data to have one data set. The reason we did that was we had a very short amount of time to provide a report to someone who had asked for it, and we were able to collect data faster by doing it in 2 places at once. And what we also wanted to do in this experiment was to be able to differentiate between the responses of people who were thought to be more sensitive to problems of what's called pattern glare and those who are not, because sensitive people in terms of pattern glare are more likely to have headaches in response to light conditions. And we had some reasons to think that the more that this light source exhibited of this stroboscopic visibility measure, the more problems it might cause for these sensitive people. So we had 2 outcome measures. One was the likelihood of seeing this stroboscopic visibility, the white dot versus the smudge. And you see that reflected in the top of the 2 charts. And you can see that as the stroboscopic visibility measure increased, there was a sharp increase in the likelihood of people seeing this, the stroboscopic effect, the white dots, with by the time it was at 3, pretty much everybody always saw the white dots, started to get kind of around the 50% mark at the 1.4 level. We also asked people how annoying they found it. They did 10 trials of each of these 5 light sources, and after the 10th trial, we asked them how annoying the stimulus was. And we looked at those data in terms of pattern glare sensitivity, low and high, and that's what you see in the bottom of the 2 charts. And what you can see is that the low and the high pattern glare groups had about the same degree of annoyingness, which was quite low. It was 1 on a scale from 0 to 4. But as the stroboscopic visibility measure increased for the light source, the people who were high in PGS started to be more annoyed by it. So they never got super high, but bear in mind that they were only seeing this light source for maybe 40 seconds at a time. So they weren't exposed to it for very long, but the people who were high in pattern glare sensitivity did find it more annoying. And that's one of the first times that people have even looked at what effects these common commercially available light sources have on the responses of people who are high in pattern glare sensitivity. So it's not going to answer the question once and for all about what's the right characteristic for commercial light sources in order to not have problems for people who are light sensitive, but it's one piece of a bigger puzzle. That being said, the findings for the stroboscopic visibility measure did have an influence on a regulatory decision in Europe, which is actually going to be limiting the ability of manufacturers to produce lamps that have a stroboscopic visibility measure that's less than 0.9. So they're going to have, sorry, that's more than 0.9. They're going to have to produce lamps that are really limited in terms of this SVM quantity in the future, which is pretty cool because it means that there will be less risk of people being annoyed by the light sources they buy for their homes. So that was an example of using an experimental approach to study a problem of real practical significance. It has a definite influence on the light bulbs that people, at least in Europe, will be buying in the future. I have to say it hasn't had the same influence in North America yet. We'll see how that goes in future. Now, I mentioned also doing field research, and in this particular slide, I'm also showing you a very complicated series of studies, actually, all in one slide. And if you care a lot about this topic, you can contact me later and I can give you chapter and verse on a lot of different work we've done on this broad topic. What we were interested in that I'm describing here is a change between lighting designs that you're probably very familiar with. It's just an array of fluorescent luminaires on a ceiling, usually an even grid over a very large space. You've certainly seen this in classrooms. You've probably seen it in offices if you've had summer jobs in offices. Probably quite typical as well of many faculty members' offices, except that if they're small, they don't have to deal with the large array of boring lighting. That's a pretty simple lighting solution that gets put into a lot of buildings because you don't have to think very much about where the lights are in relation to the people under the lights. And what we've done here is we've looked at the change between the luminaires in a grid to suspended light fixtures that throw light up and they give light down, and they're unique to each workstation, and they have better controls. And the controls are mostly designed for energy efficiency. They turn the lights off when people are not there. They dim the lights in response to the availability of daylight. And importantly for me as a psychologist, they provide individual control. And in this case, this particular light fixture gave people a control with a sliding dimmer you can see in the photograph on the lower left, which was actually on the computer in the workstation they were in. My engineering colleagues were very interested in what was the effect of these changes on energy use. So what you're seeing in the purple bars in the middle of the slide is the bottom one is showing the base case, where we started, conventional system, always on, all the time. Daily energy use was about 1.8 kilowatt hours. If you just made the change to the new light fixtures, didn't take into account any controls, that in itself reduced energy use by 42%, which is pretty huge. So the simple and stupid lighting array was pretty wasteful. But then if you add the controls, you can save another 47%. So a total energy saving of 69% if you add individual controls and occupancy controls and the daylight controls. So that's a huge energy saving, and that in itself can justify putting in that kind of system. But I, of course, being a psychologist, cared much more about what people were responding to. And in this study, we had the opportunity to go back and survey people who had the new lighting and who didn't. And we also had data on whether people were located near a window or not. And what we did using structural equation modeling with the survey data was to demonstrate that if you had control over the lighting or you were close to a window, you tended to be more satisfied with the lighting, you were more satisfied with the environment as a whole, you were more satisfied with your job, and then there was a direct and an indirect path between job satisfaction and intent to turnover. So if you're more satisfied with your job, you're more committed to the organization. And in both of those cases, with organizational commitment and directly, you were less likely to leave. So the workplace conditions, having control over lighting and being close to a window, actually had an influence on outcomes that are important to organizations, like their ability to retain their employees, which is a pretty expensive problem for organizations. And that means that putting in this really energy efficient lighting system, yes, saves energy and therefore money, but it also can reduce a little bit a big problem, which is retention and people leaving their jobs faster than employers might want. So it's a win-win, which is a pretty cool finding. And if a psychologist weren't on that team, if it was just an engineering approach, they would miss knowing that important outcome. So that's an example actually of the field investigations we do. We now do much more complicated investigations using equipment like in the photograph here. The cart that you see in the big photo is used to move around and measure local conditions in specific places in a workspace. I mentioned going across North America, and you can see one of our studies mapped out in the lower right. The pyramid-shaped device is a thing we also take with us on our field studies. We would leave that in place in one location in an office for several days to get the longer-term exposures while we're moving around and getting snapshots in different locations using the cart. And at the same time as we do that, we try to get as much archival data as we can from the organization. That has mixed success. And we also survey people using online surveys now. And boy, that technology has certainly improved a lot in the years since I was a student. Just to give you one example of kind of findings that we get, sometimes we look at whole buildings as our subject, so not individual people necessarily. What this chart is showing you is on the x-axis, the average of all of the measurements we took in each building. So each building is labeled with a letter code of particles that are less than 10 microns in size. So that's an air quality measure. And what you're seeing on the y-axis is the average illness absence that people reported in that building. So we surveyed all the people in the building, those who chose responded, and then for each building, we averaged the amount of illness that people reported having in terms of the number of days per month that they had missed because of absence in the previous month. And what we saw was that the green buildings are marked in green. You see open circles for conventional buildings here. You can see that regardless of whether the building was green or conventional, the more particulate matter there was in the air, the more illness absence there tended to be in that building. And so one of the things this shows us is that being in a green building is not a guarantee of having better indoor air quality, but also the indoor air quality really matters in this case to illness absence. So what happens to the work that I do? Well, I already gave you one example. It was an unusual win to have that stroboscopic visibility measure study actually result in a clear adoption of a regulatory change. More often, what we do is we write a report for whoever's funded our research. I'm going to talk about that in a second. Often we write our reports for industry or for other government departments. We also do write journal and conference papers. There's a couple of citations to papers on the slides that I've already talked about. And we also get involved in committees. So you see a sort of flurry of different acronyms there on the lower right. I'm active on committees in the IES, ISO, the International Organization for Standardization, and I'm particularly active in the CIE, which is the International Commission on Illumination. Others of my colleagues write documents for IEEE, ASTM, and the National Fire Protection Association, depending on the particular areas of their expertise. And this can be pretty rewarding as well as very frustrating, because it's not like you write a single paper or even a few papers, and then people look at it and go, wow, your work is so fascinating, I'm going to apply it right away. It's a little more subtle than that. You have to learn how to influence people, how to explain to them clearly what your research is and what it means. And often these people are not psychologists. And as I mentioned, they may not even have taken intro psych. So it takes a little bit of time to perhaps get the credibility with them that what you're doing is just as scientific as what an engineer might do. But at the same time, when you do manage to influence people, it can feel very rewarding. My organization is also responsible for the publication of the National Building Codes. And these days, we're also very concerned with the National Energy Code of Canada for buildings. And so that's another route to try to get our work applied where it's appropriate. We don't write any of those documents, but we host the committees that do, and it has to be admitted, we have, a little bit of an in trying to reach the right people and trying to influence them to see that our research results do get applied and have a benefit for people in the various routes that the topic matter that we are studying. Now, I'm sure you're all familiar, having heard your professors talk about it, with the challenge of obtaining research funding. It's important for me to mention that the NRC is not a research funding agency in general. There's, NSERC and SSHRC and CIHR that you may have heard about. But equally, I'm not eligible for funding from those routes, from those particular agencies. We spend a lot of time, just as a professor does, trying to get research funding for the work we want to do. And the organizations we work with are pretty variable. They are other government departments. So I do some work now with Natural Resources Canada and with Public Services and Procurement Canada. But I also work with private industry. Access Lighting is a Canadian manufacturer I work with. We have done some work in the past with the Royal Bank, and I'm very involved in that household energy use work with New Brunswick Power. So it's an ongoing interplay of talking to different parties, convincing them that we can do something that's useful for them, and that in fact it's in their interests to come on board and fund collaborative work where we may bring together many different kinds of funders to answer a question that has dimensions of interest, both public interest and to their private interests as industry. So that can be an interesting challenge in itself, and the skills involved in doing that kind of work are definitely not ones that you walk out of university having. It takes a while to learn those. But it is part of what makes this job really interesting, is learning how different parts of society work and having the ability to sort of grasp the complexity of how different systems operate as well. So just before I wrap up, I want to highlight that although I've talked about the NRC, and I think the NRC is a great place to work, there are a lot of other government jobs for psychologists, and all of these places have student employment programs. So if your interest is not particularly environmental psychology or one of the other areas that is relevant to the NRC, you might want to take a look at other government departments. So the Public Service Commission is responsible for hiring in the main government departments. For example, there are psychologists employed in the Public Health Agency, the Department of National Defence, the Correctional Service, Statistics Canada, and in the Public Service Commission itself, there's a unit called the Personnel Psychology Centre, which has a lot of IO psychologists on staff. So if you go to the Public Service Commission website, you can see many jobs advertised there, including the summer and co-op student employment programs. The way the government is structured, there are agencies that are allowed to manage their own employment separately. And so although you can apply to summer programs through the PSC, if you want to be considered for jobs at Defence Research and Development Canada or the NRC itself, you have to go to their website separately. And we do have summer employment programs. And I will say that in the last year, as a response to the pandemic, there has been a lot of government money for student programs. It's been part of the general government response to the pandemic. And so you are highly recommended to be looking there for jobs. They are, of course, now it's a little bit late for the May to August time period. We've mostly made our hiring decisions for the summer, but certainly at the NRC, we do have positions over the fall and the winter terms that will get advertised in due course. And there's a database that you can submit your resume to at any time. And it's useful to get in the database because, then you're there and you can be found for any particular job that may come up. So in wrapping up, I want to leave you with a few closing thoughts. One is that it isn't necessary that you have the specific skills for everything you will do at the minute that you walk out of graduate school. I'm assuming most of you will go to graduate school. What is really important is that you have generalizable skills. One of the best pieces of advice I had as a student in graduate school was from my professor, Robert Gifford, in which he said, okay, you can specialize in whatever you want. In my case, it was environmental psychology and lighting, but make sure your minor is something that is going to be useful to everybody. And that's true even if you're going into academia. So in the system at UVic, I had to do comprehensive exams in my major field and in a minor field. And on his advice, my minor field was research design, because that's something that every university always needs to have taught and that everybody always needs. And in hindsight, that was great advice because, as you saw, I use a lot of different research designs in the work that I do. And I couldn't have known that at the time I was making that decision. So I heard someone else recommend having a lot of skills for data management and taking extra training to be really proficient in SPSS or R or whatever statistical packages you may want to use. That is excellent advice, because no matter what you go into, if your job involves any kind of research later, those generalizable skills will come in handy. It's also really important to be open to opportunity. The job that I have now, I honestly did not know existed until probably about 6 months or so before I finished my PhD. I thought I was going to go off and do a postdoc somewhere, and then I was going to go off to an academic job. After all, that's what I had been trained for. I started talking to some former professors actually from Manitoba, and was led to discover that, hey, lo and behold, there's interesting lighting research at the NRC. I threw an application into them thinking that I was going to come here for about a 2-year postdoc, not realizing that in the minds of the person hiring me, those 2 years were really more of a trial period for what they thought might be a longer time. And as you've heard, I think, or inferred from what I've said, I've actually been here since I did my PhD. So that's closing in on 30 years now. Being open to that opportunity when it presented itself has worked out well for me. It is also really important to maintain your own integrity, to be clear about what your own goals are and to continue to pursue them. At the time I graduated, and I think this is probably still somewhat true today, there were not a huge number of jobs for psychology faculty members in Canada. And I was advised to look elsewhere, particularly in the US. But I knew it was really important to stay in Canada. That for me, that was just a personal, importantly, thing I wanted to do. I didn't want to move to the States, or I didn't want to move overseas. Some people thought I was pretty crazy not to be applying everywhere that I could, but that was actually really important, and I'm glad I persisted in that. It's worked out well in the end, and I'm comfortable with the life that it's led me to. So I think it's really important to persist with that. Do make friends everywhere you can. Learn to network, learn to communicate. Of course, these days we do a lot of that online, but also when you have the opportunity, when things open up again, take the chance to attend some conferences in person. Do talk to people, because if they've made the trip to go somewhere in person, that's why they're there. And everybody is always happy to meet someone new and to make new friends. And often, if you know a little bit about the person before you introduce yourself to them, they're flattered by that groundwork that you've done. And so don't be afraid to approach someone who may seem a little bit more experienced or more senior. They'll be open to what you say, as long as you you know what you're talking about, and you come at them with a friendly approach. Being flexible in your career is important. That's certainly something that I've had to practice along the way. I mentioned my detour into household energy use. That wasn't my first choice, but that can also lead you to some new opportunities, new friends, learning new things, and can lead you down paths you wouldn't have thought of on your own. So that flexibility is also something I can commend to you. And I have to admit, don't overlook the sheer dumb luck that can lead you into a good place. I feel pretty fortunate to have landed where I did, and certainly wasn't because I planned to be where I am. So here's to dumb luck as well. That's the end of the formal presentation that I have, and I hope that I've managed to spark some questions in people.